In this video, we are going to see the topic on Lex tool specifications. What is a Lex tool means? It is a tool used to generate the lexical analyzer. So the Lex is a program that generate the lexical analyzer. It is a two phase of compilation. So the lexical analyzer is a program that transforms our input stream into the sequence of tokens. So the function of Lex is as follows. So first the lexical analyzer sent it to the we are creating the Lex language. Then the Lex language is given into the Lex compiler. The Lex compiler convert that lexical program into that lex.yy.c, that is convert into the C program. So that C program is given into the C compiler. That C compiler is compiled, and after compilation it produces the executable file. That executable files is ready to run. So when you are giving into the input stream input data, that executable file is given, that whether the given input is correct means it produces a sequence of tokens. So this is the Lex specification. So the lexical analyzer, the Lex is the first program. That Lex program is given into the Lex compiler, that is converted into the C program. That C program is given into the C compiler. After that, that executable file is run by the when you are giving the input, that executable program produces a scheme of tokens. So the first term is the first specification is lexical program. So the structure of Lex program is given below. So what is the structure of Lex program is it contains the three parts. One is the definition part, that is a declaration. In the definition we have that declarations. So after that followed by the translation rules. So the translation rules is written in between the percentage followed by the open brace. Then next we have the percentage followed by the close brace. So after that we are having that percentage that indicates that the translation rule is started. After writing the translation rules, that is end with the percentage followed by the percentage. Finally, we have the main program, that is a user defined auxiliary programs. That is the three parts of specification contained in the Lex program. First we have the regular definition, and that we are declaring the C declarations and the header file declarations. All the things is done in the regular definition. So that after that we are having that translation rules, and finally we have the user defined auxiliary functions. The translation rules are in the form of, first we have the regular expression. So based upon the regular expression, the action is given. So we have a set of P1, P2, Pn. So for particular P1 we have the set of action 1. So the action is enclosed by the open and close braces. So this is the rules of syntax of translation rules. So the definitions include the declarations of constant, variable and regular definitions. So we have the definition section. Next we have the rules section. The rules define the statement in the form of P1. Based upon that we have an action. So the P1 indicates that regular expression. So based upon the regular expression, what the action and what the action one describes in the action, what that action will be defined in the braces. Then followed by the translation rules, we are having the user subroutine. So the user subroutine are the auxiliary procedures readed by the actions. The subroutine can be loaded with the lexical analyzer and compiled separately. So finally the starting is the user subroutine program. From the user subroutine program, it called the declaration section and definition section. So this is the Lex specification. So in that Lex program, we are using that lex predefined variables, that is that y text, y length, and y in, y out, all the predefined variables are used. So what is the yy text means? And the string contains the lexeme is a yy text. So the yy length means length of the lexeme is specified. Suppose the input stream pointer to the default, we have the yy in means we have that is like a stdin, std out, std out, we are having the output stream. So that output stream in the is specified in the lex program like yy out. So this is a predefined variables are used. Next we have the lex library routines, that is the yy lex, that is a default main contains the call of yy lex. So we have a main program, that main program contains the yy lex program. Once the yy lex is called, the execution is started. Next is that yy more and yy less, these are all the lex library subroutines are used in the lex program. So this is example of lex program. So you know that what is the lex specification is there. We have that definition section. So the definition section is enclosed in that percentage open brace followed by the declaration or definition, and end with that percentage and close braces. So that is the definition. Next we have the translation rules. The translation rules start with double percentage are followed by that regular expression followed by the action. So here the regular expression is 0 to 9 plus, that is a that specifies the numbers 0 to 9 numbers patterns. So that what is the printf we have to do means we are printing that particular lexeme. For example, our input is in between 0 to 9 means that input is printed in that particular statement. So it match with the regular expression and print that particular action. So this is that this program implies that when you are giving the input as a number, that number is printed in the output stream. So followed by that main function, that is the user auxiliary procedures. So the main contains the yy lex function. So the yy lex function invokes the lexical analyzer, read the input and produces the output as a token. So this is a sample and example of lex program based upon that three specifications. I hope you will understand how the lex program is specified and how the compilation is done. So in the compilation, the lex program is given into the lex compiler. That lex compiler produces that convert that lex program into the C program. That C program is given into the C compiler, and finally it produces the executable file, and that executable file is used to execute the get the input and produces the output as a token. Thank you.